Hi everyone, my name is ZK. Yes, I'm sharing the same name as Zero Knowledge. Yeah, this is really where I hope that there's a ZK passport for me to actually verify my identity and show to everyone that's actually my real name. Yeah, so I'm a DevRel engineer from Aleo, and Aleo is a new layer 1 blockchain. We are not a rollout, but the Dora from previous presentation will be able to find ZK in our blockchain because you are a privacy focused blockchain, not only privacy, but also providing programmable privacy to everyone. What does that mean? It means that the developers now has the ability to build general purpose application with privacy by default without a lot of complexity to deal directly with all the math complexity in ZK. And yeah, and to start this off, I'd like to use this analogy to HTTPS, which is the transport layer security, or SSL, to show that Aleos envision a future of blockchain industry with privacy. And as you can see, what TLS or SSL brings to our existing internet is that it enables economy activities possible on internet, right? So without encryption, it's impossible to have economic activities such as e-commerce, because the moment that you try to do something with your credit card online, you will just show to everyone, and that's just not possible to have a transaction online. Oops. And yeah, so with privacy built into Web3, we are now finally have the ability to have more real-world use cases in all these sectors, including finance, identity, gaming, and ML. There's one interesting example that I got it from talking with people yesterday. So the shipping industry is looking to digitalize their document, including bill of lading, which is a legal document that proves that their shipments has been carried in. I mean, just in simple, it's on the way in their shipment, and that document can use for use cases such as financing, where while you are waiting for your goods to arrive as a supplier or buyer, you can use that document to actually get financing out of it. But without privacy, imagine to put this on chain, because blockchain is great for settlement for use cases like finance, right? But to actually use that is just impossible on public blockchain, because everything will be shown to everyone, including your competitors. So without privacy, it's just not impossible to onboard this kind of industry to blockchain. So this is just a short history of Web3, and Bitcoin started the whole crypto economy security so that we can now have trustless value transfer. And Ethereum started general purpose programmability, and now we have more interesting and complex application built on top of blockchain. So Aleo is the first one to provide programmable privacy to everyone, to unlock more real-world use cases on blockchain. So this is just a repeat of what I just mentioned. So Aleo is the first ever permissionless, programmable, privacy-preserving blockchains. It's a combination of three of these things. Yeah. So yeah, and we like to say Aleo is ZK by design, but before going into what that actually means, let's look at how existing decentralized ledger works, which is our existing blockchain. And first thing that user interact with the blockchain, what they do is they submit a transaction, including the application they're going to run and their inputs and signature to approve that transaction. And what does the node does next is it re-execute computation in the transaction, not only in one node, but in all of the node, taking Ethereum as an example, to actually verify that your computation is correct. So that's the way that how public blockchains verify your transaction. Yeah, so if you look at the third step, is that if the computation is correct and the signature is valid, then the state of the application get updated. So there are some limitation on this kind of architecture, right? So there's a limited runtime, especially because if you don't limit runtime, it will just cause denial of service for all the nodes. So that's why on public blockchain, you can see there's gas fee that charge on top of the runtime that you're going to run. But on Aleo, technically there's zero gas fee for your computation, because how we are running your computation is also by doing client-side proving, which is just to generate a proof of like a zero knowledge proof that attests to your computation is run correctly locally on your machine. And what the network does, it's only by verifying that proof, which is succinct and almost instant, it can immediately know that your computation are running correctly and thus updating the state difference. Even though if your computation runs for weeks or years, so we can technically have unlimited runtime on Aleo. So there's two problems with decentralized ledger. So the first one, you can see with the limited runtime, it hurts scalability. That's why right now we are seeing a lot of rollups to offloading all the executions works of Ethereum in order to make it more scalable. And secondly, the architecture of public blockchain just hurts privacy. And yeah, so Aleo, it's built on top of this idea called, or this paper called ZK, and ZK provides an idea on how to run a zero knowledge execution in a decentralized setting. So first of all, we are using ZK Snark. It's called Varuna, the proving system. So first of all, we run a trusted setup. It's only one time. And after that, we get public parameter from the trusted setup, and we can reuse the public parameter in all our programs afterwards for user to generate proof and run their programs, and also for verifier to use the verifying key to verify the program or the actually circuits is running correctly. So on Aleo, we are using record models. It's more similar to UTXO model compared to account-based model, because you'll see why we are using UTXO model instead of account model, because there are some privacy properties with it. So if you look at how account model works, it's simple, straightforward for developers to manage states for multiple party, because as you can see everything in clear. Some user send a transaction to prove to the network with some data, his signature, and the account of the smart contract get updated to a new balance and new storage. But you can see there's a problem of scalability and also very high fees, especially during times where there's a lot of queue of transactions, and also there's no price. So let's try to make it in a private, turn it into a privacy model directly. It's very straightforward. So what we do, we turn all the values and data, we encrypt the data, we commit the value, and turn the code into predicates. So, but although now we have privacy on our data or the state that we're trying to update, but there's no concurrency, because if you look at this design, the whole program state are now storing as like a commitment, or yes, like a commitment. So imagine you have two users trying to update the state. If they are trying to update at the same time, one user will fail the transaction, because the time that the commitment gets updated, the another user should use the updated commitment to update his state, because that's the latest commitment, right? If you are using the commitment that is previous, it should fail to prevent your double spending on a state. And still, there's no privacy because you can see everything is still indexed by account, where you still can see who are the one who interact with this program or this smart contract. Yeah, so these are a few properties. Now, using zero knowledge, you can have you don't need to do ledger re-execution again, and there's data privacy, but there's no account privacy, and there's no efficient state update because you have to consume the whole program in order just to update some state. And then, of course, there's no concurrency, just what I mentioned just now. So on Aleo, we are using a model called record model. So now user, as an owner, his address is encrypted because we are no longer need to know who interact with this program again, and he sends transition that consists the target program that he's running with records, both old and new records, and with fees and proof. So what the record does is, right now, instead of storing or committing the whole program state, right now the commitment it's only ties with the user, its owner, and every user they have their own records that kind of storing with them, or storing encrypted on chain, which is only decryptable by their private key. And this way we can have concurrency, because if you try to update the records now, it's only dealing with your own record, and you can have multiple users that are interacting with their own record with the same program. So this is how we achieve concurrency, and there's no double spending because there's a commitment tree that stores the records and nullifier to make sure that no single record will be available to consume twice. So with this model, now we can also enjoy account privacy and efficient state update, because right now the predicates is only consuming a record, like user-based record, instead of the whole program. And concurrency because of that. So Aleo introduced this kind of new model of decentralized computation as comparison to Ethereum. In order to be more scalability, you realize you depending on rollup to offload your computation, but at Aleo, we have the scalability since the beginning because we're already doing all the execution off chain by every user. And at Aleo, we are using the proof system called Varuna. It's an improved version of Marlin, which enables batch aggregation, which simply means batching of the transition. So every transaction on Aleo, it consists of a lot of transitions, where every transition has its own proof. So transition is basically means just a single function call. You can have multiple function call in a single transaction, but the transaction has a proof that attests to all the single transaction. And yeah, and Varuna has a very tiny proof and very fast verifier in just 3 milliseconds. All right, and these are all the stacks of Aleo. So at Aleo, the developers write program using our DSL called Leo. We abstract all the complexity of to deal with zero knowledge like circuits using Leo, so that developer can easily write program with programming language that feels more similar to their everyday language. And after that, once the program is written or deployed on chain, the approval, which is also the user themselves because it's running locally in their machine, or it can be delegated to some server elsewhere. And the stack they are using is called SnarkVM, the virtual machine of Aleo, to run the program and generating proof after the execution of the program. And SnarkOS is basically the node client run by validator to verify all the proof of transactions. Yeah, so this more information on Leo, and this is how the syntax looks like. To write a function, we call it transition. Transition basically means things that are going to run off-chain. And similarly, you can place a function identifier, define your own parameter. If you don't define the visibility of your parameter, it will be default. It will be privacy by default. So example here, if you see the bidder and amount, if there's no public visibility beside it, it will just privacy by default. What people can see on chain are only ciphertext, which is only decryptable by its owner. All right, this is just more information. So what Leo does is it takes the program that developer writes, compile it down to intermediate representation. We call it Aleo instruction. And the Aleo instruction will be run in AVM to execute the program and generate proof. Yeah, this is just, again a diagram to show the life cycle of Aleo development. Yeah, and this is the comparison of with a few different similar projects on Aleo to verify a proof. It's very cheap. The reason why the others are more costly because they have, like example, they are using proof system that have larger proof size, and also to verify a proof on Ethereum, it costs a little bit more, and the settlement time for Aleo is only 15 seconds, which is very fast compared to others, like Stucknet, ZK Sync. The reason why is because they have a fixed epoch to batch all the aggregate all the transactions they have before posting back to Ethereum, right? So it's kind of like a trade-off between fees and settlement time. You can have faster settlement time in rollups, but in turn it will cost a lot more per transaction because although the fee showing here for proof verification is high, but because they are actually doing aggregation underneath, so per transaction is still, I guess, cheap, but it's a trade-off between both. This just show how far we go in terms of all the hardware acceleration. So yeah, so one thing I want to mention is at Aleo we also run an effort to accelerate the hardware, the development of hardware in terms of proving hardware. So at Aleo we have a proof of succinct work algorithm to incentivize all the hardware provider to accelerate their hardware. And you can see the Coinbase rewards is the proof of succinct work that we run. All right, and just some data to show. There's just on Aleo testnet, we already generate 5 billion proof per second compared to others. So what this means is we are actually creating a market demand for all the service provider or hardware manufacturer to incentivize them to come out with better hardware. And there's a few product at Aleo we felt that those are big use cases. ZPass is ZK identity use cases on Aleo. And this is just showing how it works. And with ZPass, we can now have both privacy and compliance. And this is the best use cases for stablecoin because to actually send payment to everyone compliantly, you have to have some way to do the compliance check, and ZPass is one of the use cases. And ZKML is also another use cases that we are looking for. So yeah, so this is just some of the data that we gather online. So this is just showing that a lot of projects, they are taking different paths or taking different trade-off. But all together, we are all trying to push ZK to to provide a better use cases for Web3. Okay. And lastly, this is my Telegram. If you have more questions about Aleo, you can contact me through Telegram. And yeah, thank you.
Thank you,
that's all.
ZK. Any questions for ZK? I'm curious about your plan to switch to a new prover standard,
Sorry, what does
like
that
the
mean?
new
Is it
ARC standard.
like switching? Oh, okay. Yeah, if you are mentioning about the ARC that we have right now, it's ARC 43. It's not a new prover standard, but we are looking to upgrade our Coinbase puzzle algorithm to have a full snark verification. And what this brings is this helps verifying those puzzles more easily, because right now it's not using a full snark verification, like verifying just a ZK proof, which is very quickly. That's one of the advantage of doing that. The another reason of doing this is also to come up with a better algorithm for the miners or the prover in order to incentivize them to accelerate their hardware.
When will it be implemented?
Yeah, so right now this is our most immediate or our most concerned issue right now. I guess it will implement very quickly. Yeah, soon.
Thank you.
Oh.
Oh, we have another question?
Oh. Hi, good talk, thanks. So you use a rank 1 constraint system for your representation of the circuit. Does that, at least my experience with it is that it can lead to a bunch of redundant constraints. If you don't have like a lookup available to you, do you use any tricks like that to avoid repeating certain sub-circuits or anything like that?
Sorry, where are you? I couldn't find you.
I'm over here.
Okay, sorry. Yeah, so you're mentioning we are using R1 CS, right? Yeah. So right now, how Varuna works, from my understanding, it batches all the proof together, like every circuit or every function call, it gets compiled into a circuit form, and it runs proof that every individual function or transition that has proof, and then every transaction, it will batch all the different proof together to come up with only one single proof that will send on chain finally to do the verification. Yeah. Do I answer your question correctly? Yeah.
Great. Thank you.
Okay, thank you.
Thank you, ZK.